This is an IntelliQvic programming demo for Sodick Wire EDM. We're going to make a quick example of a 4-axis punch by importing a parasolid file. So when we're at the user interface on the screen, across the top is our selections for our view, ISO view, top view, front view, so forth, and your zoom and pan, those functions, wireframe or solid form. On the left side is your manager window. This pane over on the left switches depending on what screen or function you're in. Across the bottom then is your file page for opening and closing or saving IntelliQvic files. The model button on the bottom is to import files, be DXF files or parasolids. And once you import them, that's the screen we're on now, you have a place model function. So if the 00 is in the wrong spot, you can move the part. So what we'll do is we'll import the file and get that loaded. So you hit the little file icon button and you can either import parasolid XTs or XB format. We'll bring in part 1, click open. So here's our punch. I'll put it in isometric view. And with the wheel of mouse, I can free rotate the part on the screen. And hit ISO view, top view, wheel of the mouse. I can zoom in, zoom out with the wheel of the mouse too. Okay, so the first step would be to make sure you have the part orientated for 00. If not, they give you this place model function. I'll do a future video on how to move the part around and shift your 00, but this is what this is for, to put your 00 at pickup of the block. To program the part, first step is to do what we call feature recognition and the contour extraction page. In here, it's going to find the thickness of the model already. That fills out already. And then you say if you want to search the model for all shapes, punches, or die cuts, or you can say just search for die shape cuts or just search for punch cuts. This only has one model on the screen and there's no holes in it or anything, so we could say all or punch, no difference. Then you hit the extract. So what this step does is search your entire model for everything that's wire EDMable, holes or outer cuts, punches, dies, and so forth. So being this is a simple model, it finds the one cut and it shows it to us here at the bottom and in the bottom left. If I click on it, lights up this green color, so that's what it found, which matches the model, which it's correct. Okay, next step is to put a start hole on the part. So I'm going to put one up here at X0 and Y. If you look down in the bottom right, it gives you where your cursor is right now. So if I just freehand one in here, I'm going to want to put it at a position that I know of. I'm going to put it at Y.5. So I got the mouse right now at 0.55. So I will turn on the starting hole function and I will put it at Y.5. And it creates a little wire start hole for us to use for the toolpath. Now, if you're doing a die with multi-holes, multi-pockets in it, it has a function to search the entire block. There's a starting hole search function. So if you have little circles drawn in for your start holes, it'll search for those. And you would go in here and tell it what the max size is for your start holes, and it'll search all your circles. And if they're within that size, it will change them to be, instead of cutting circles, it changes them into wire starts. Okay, next step is machining path and path generation. And we are going to turn on the automatic, which is to automatically find the start hole is what that's for. And hit generate path. First thing is to set the power settings for the wire EDM machine. We fill out this menu for your wire size, wire kind, workpiece kind, workpiece thickness. It's almost 2 inches, so I'll select that one. punch, nozzle position. If you're going to have your flush cups close, top and bottom, you could pick that. If you got to set the block up where the upper head's distanced away off the top, you pick open U, and how many passes you want to take. So I'll have it set for 3 passes or up. Now this menu here that's displayed right now is not the same one on the machine. This is not configured right now. This is my PC. It is not the machine, so it's not connected to the machine in any way. When you run the desktop version, you have to have the right database which matches your machine in the software, which I do not have at this moment for this machine. So anyway, I'm going to set that kind of generically to move on forward. Now we have 3 or up, so we need to pick a surface finish. So we'll pick this rougher finish choice here, and it's a 3-pass technology. It says 3 times here. If I wanted a better surface finish, I could pick these better surface finishes, and this changes from 3 time passes. If I build a better finish, it'll be 4 time passes, or a little bit better, it'll be 5 time passes, so forth. So I'll just set it on 3 and OK. Next step is to set your glue stop. So we'll put the stop width, tab width here in the residual stock at 50 thousandths. And the avoidance, this is going to be the little move when it makes the punch. It's going to cut around to the tab position and back off the shape to retract off the face. And I'll put in 50 thousandths there too. And it's completed, so the program's completed right now. So this is the little glue tab hold on, and that's the little retract that they call avoidance. So that's completed. Now we go to NC conversion, convert to NC, and put a name in here. We'll say sample 1, and we'll convert. Now if you were at the machine, you hit the graphics button on the machine when you're in the edit page, and it'll draw the G-coded program up as a graphic. Being it's not attached, I'm not at a machine, I don't have that window. So let me exit out of here, and I will show you the code that it just created. And it's in my IntelliQvic NC files, and here's sample 1. So this is the G-code program that the IntelliQvic made. So it's a program ready to go to the wire machine. We have our cutting power settings here at the top for the 3 cuts, C1, 2, 3. And our offsets, H1, 2, 3, are sitting here at the top for wire offset compensation. And then the regular program begins here at G90 and on down. So there's your 3 passes. One thing to note, we're a 4-axis program, but our control does 4-axis with circular interpolation. So some of the older controls don't have the advanced capability that a Sodick has, and it writes a GO1XYUV format program, even though you're doing circles, or arcs I should say, breaks the program up into all line segments, right? On a Sodick, it doesn't work like that. You got true geometry, GO3, XYIJ, then there's a colon here, and another GO3, XYIJ. So this is the bottom geometry on the left with the top geometry on the right, bottom, top. So it's 2-axis programs basically sandwiched together, isolated by that colon. It's a unique format for 4-axis on wire EDM. We've been doing it this style for over 20 years now. So it gives you true geometry for 4-axis, because a circle or a corner radius is a GO3 or a GO2 code instead of broken up into, maybe 10 or 15 straight line moves. So that's example 1, 4-axis punch example.